Hello, good evening, and welcome to our Advances in Research webinar with Dr. Catherine Dodd. It's lovely to have so many of you joining us today. We are an international session today, so I should say good morning and good afternoon to all of those joining us from around the globe. It's lovely to have you with us. If anyone has any hearing concerns, you can enable closed captions under the CC button at the bottom of your screen, and you can also change the language settings in there if you choose. If our faces are in front of any of the slides, you can move them using your mouse either to the side or up or down, whichever suits you. So my name is Tracy. I'm one of the National Support Coordinators at MyAware, and I'm joined today by my colleagues Laura and Vicky, who are working away in the background on all things technical, and of course Dr. Dodd, who you will meet shortly. So a little housekeeping before we start. Your cameras and microphones will remain off during the session, but you will be invited to ask questions after the presentation using the Q&A function at the bottom of your screens. This is because we often find some questions will be answered as we move through the slides, and it can often be distracting for those presenting. After the Q&A session, we will have a few poll questions for you, so if you can stay on to the end, we would really appreciate your feedback as it helps us with future sessions. So, with all that said, and without further ado, I will hand you over to Dr. Dodd.
Right, that's great. Thanks very much, Tracy. Just see if I can get onto my slide. Yeah, thanks. So I'm Dr. Catherine Dodd. I'm a Neurology Clinical Research Fellow. What does that mean? Well, it means I've been a doctor for about 14 years. I've been a neurology doctor for about 10 years, and I've been particularly interested in myasthenia for the last 3 years, working in the Myasthenia Clinic in Manchester and doing a PhD in research in myasthenia at the University of Manchester. So I'm really grateful to MyAware for inviting me along to give this webinar today. I don't really have any disclosures, and I've not received any funding from any of the pharmaceutical companies. I have had research funding from the North Care charity, which is part of or associated with Salford Royal, where I work, and from MyAware, which I'm really grateful from, and a company or an organisation called the Neuromuscular Study Group. So there's quite a lot to do. I'm going to try and give you an update on current research in myasthenia for about half an hour. There's a lot to pack in that half an hour. There's quite a lot on some of the slides, and I might not be able to get through it all. I'm going to keep an eye on time. What we are doing though is recording this, and so you can go back through and have a look at what's on the slides at a later date if you'd like to. Part of this came about because I wanted to get your views on future research in myasthenia. So I'd like to continue doing research in the condition. And as part of developing future research strategies, it's really important that we get feedback from people affected by the condition. So thanks to those who filled out the questionnaire so far, and I'll give you a summary of the results that have come back, but also an opportunity for anyone who hasn't filled in the questionnaire to do so. And then we've got questions, ones that have been sent in so far, but we'll also open up the chat right at the end for any additional questions, and I'll do my best to try and answer them. Now, myasthenia, as you know, is quite broad, and I might not be able to cover everything. I think the majority of what I'll be talking about will be acetylcholine receptor antibody positive generalized myasthenia, but I will try and cover some of the other subtypes as well. So myasthenias, there's 3 main types. Myasthenia gravis, there's a condition called Lambert-Eaton myasthenic syndrome, and there's also congenital myasthenias, which present very similarly, but are different. They're not autoimmune, and they tend to present with symptoms in childhood. Myasthenia gravis itself can be divided in various different ways. So you might divide it by antibody. So the majority of people, about 85%, will have antibodies against the acetylcholine receptor. Some patients, about 4% of patients, will have antibodies against MuSK, which is a protein that lives near the acetylcholine receptor. Some patients have antibodies against LRP4, another protein in the similar area. And then there's a good about 10% of patients who are what we call seronegative, which means they don't have antibodies on the current tests that we have available. We also sometimes categorize people by what we call phenotype, which is how you present clinically, what your symptoms are. And broadly, we might divide people up into having ocular symptoms, so those affecting the eyes, double vision and drooping eyelids, or those who have generalized disease where the muscle weakness can affect the speech and swallowing muscles, the limb muscles, breathing muscles. And we can sometimes also divide the condition into whether the onset. So there is early onset, which is generally females in the 20s. And that's a bit different to the patients who present with late onset, usually in their 60s, 70s, and that's more males. There's also 10% of patients have the condition due to a thymoma, a tumour in the thymus gland. So we know that it seems to start in the thymus. The thymus gland sits behind your sternum. And what it's meant to do is sort out the immune system. So the immune system makes lots and lots of immune cells, T cells and B cells, which are there to fight off infections. But to do that, there's a lot of T cells and B cells generated, and the thymus is meant to sort them out. And if they're going to attack part of your own body, get rid of them. Something goes wrong in myasthenia, and you end up with B cells that make antibodies that attack part of your body, part of the neuromuscular junction. So to make your muscles move, the nerve needs to send a message over to the muscles. They send it via a chemical called acetylcholine to this green receptor, the acetylcholine receptor. And what happens with these antibodies, particularly the AChR, is they block these receptors, they reduce the number of receptors, and they also activate the complement system, which is part of the immune system, which leads to damage at the muscle membrane. And until recently, we've not had a great deal of change in the treatments that we use for myasthenia. So most patients will start off trying pyridostigmine or mestinon, which reduces the breakdown of this chemical acetylcholine. Often that's not enough, and therefore we often will use prednisolone, corticosteroids, which are the bane of many of your life, which reduce the number of immune cells, but do so within a few weeks generally, and try and bring things under control. And if we can't get away with a low enough dose of steroids, we often need to use long-term immunosuppressive drugs. So that might include azathioprine, mycophenolate, and in some cases, we'll use rituximab, which completely gets rid of your B cells. We also know that thymectomy is beneficial, so getting rid of the thymus gland in those under 65 helps reduce how much treatment you need long term. And in an emergency, in a crisis, we can use things that get rid of these antibodies, so IVIG or plasma exchange. Those treatments work quickly, but they only last about 4 weeks and come with potential risks, so we don't often use them as long-term treatments. And what do we know about how things have changed over the years? So this was a study that looked at what's changed going back to 1940 to 2000. And first of all, before we had good intensive care, critical care, actually there was a much bigger proportion of patients who would die because they couldn't survive a myasthenia crisis. Actually, that's significantly improved, and most people will now survive a severe crisis because of good support on intensive care if that's required. We can see that there's an increase in the number of patients that have improved. So we can improve the condition in more patients than we used to. But what's really interesting is if you see this little graph, this is patients that go into remission. Actually, that's not changed. And so we're not bringing more patients into remission than we used to. And there's increasing sort of acknowledgement in the research that patients are suffering. And although we're improving things, often patients may have ongoing symptoms. So in Sweden, they managed to look at 1,000 patients, which they think is about 40% of all of the patients in Sweden with myasthenia. And about half of patients complained that they still had moderate or severe symptoms. Again, similar results in Germany. They looked at 1,500 patients, and compared to those without myasthenia, patients reported lower quality of life, and 2 out of 3 had had to change their work or their income had changed because of their diagnosis. Many patients had ongoing symptoms, the most commonly fatigue of the eyelids and difficulty breathing. I think this is probably slightly skewed in that the people who are mostly affected are more likely to participate in these surveys, but it does show that there's a lot of people out there with ongoing myasthenia symptoms and a need to find better treatments. we know that our current treatments also pose a lot of side effects. And this was a study that Myware helped me with. We sent out a survey, and I'm really grateful if any of you completed it. Steroids, we know, prednisolone is in purple, cause a lot of problems. So 2/3 of patients complained that it caused weight gain, changes in appetite, as well as sleep problems, mood or memory problems, thinning of the skin, thinning of the bones. And unfortunately, at the moment, we do rely on prednisolone quite a lot to bring the condition under control. Pyridostigmine is used a lot, and half of people complain that it caused diarrhea or stomach cramps. And then we were looking really to compare between these immunosuppressant drugs that are used, azathioprine, mycophenolate, methotrexate, and this is how many people continued it after they started it. And we found that azathioprine, although it tends to be recommended as first line, over half of the people that had started it had to stop it. And that was mainly because of problems with the liver. It's still an important drug. We do monitor the liver blood tests very carefully. And I think it's going to be a long time before we replace these drugs, but I think it's important that we get a bit more information about how they affect people and be monitoring that. Now, there's been a change and there's been a shift, and this is looking at PubMed is a website where we will look at research output for medical conditions. And if you look compared from 1990 to the most recent day, in the last 4 years, there's just been a great increase in the number of publications that mention myasthenia. And that's in part because the drug companies have suddenly taken an interest in the condition and started to run clinical trials, which historically seemed to be very difficult to do. So we talked about the previous treatments, and now, I'll come back to that in a second. Just one of the first big trials that kind of kicked everything off was in 2016, where they did a big trial of thymectomy. Thymectomy is where you remove the thymus gland, and that can be done with a big scar down your sternum, but most commonly now by keyhole surgery. And this showed that if you take out the thymus gland in those under 65, particularly in the first few years of diagnosis, then you reduce the amount of steroids that someone will need, and you also improve their condition. The quantitative myasthenia gravis score is a severity score. So those who'd had a thymectomy had a lower severity score and a lower dose of prednisolone. Doesn't cure it, but it improves things. And actually, suddenly there's a load of new treatments coming out and being investigated in myasthenia. And this has just dramatically changed over the last 4 or 5 years. I'm going to talk you through some of the new drugs that are coming through, but to do that, I need to just give you a bit of context about how drugs are developed and how they come to be used in the NHS, particularly in the UK. So after initial lab-based research and finding a potential drug, they'll go through a phase 1 trial just in a few patients who are healthy to see if it's safe for use in humans. Then go to a phase 2 to see if it works, and usually this is a dosing study to see roughly what dose would be a good idea to use in people with a condition. And then to a phase 3 to see how well it's working and do the benefits outweigh the risks. And if you get a positive trial in a phase 3, then the drug company will usually then submit this to be approved by, in America, it's the FDA, and in Europe, it's the EMA. So that initial bit probably takes over 10 years from drug discovery. Then there's approval from the EMA and the FDA. And then in the UK, we'll wait for marketing authorization by a company called an organization called the MHRA, which regulates medicines. This will all take about a year. And then we need approval and appraisal by NICE. So NICE is the National Institute for Health and Care Excellence, and they're in charge of deciding what is cost effective to be used in the NHS. Because as you know, with the NHS, there needs to be equitable care. So everyone needs to be given the same opportunities for treatments, and therefore there needs to be a decision nationally about whether drugs are cost effective and who they should be given to, which patients should be given priority. So this appraisal and decision about funding from NICE usually takes about a year, and then obviously there's a little bit of time where different hospitals or different departments need to mobilise and work out how they're going to deliver that drug, depending on how complicated it is. So I'm going to talk through 5 different categories of treatments that are coming through for myasthenia. So the first is complement inhibitors. Complement, as I mentioned, is part of the immune system. It helps us fight off certain infections, but it is very complicated. This is a nice simplified version, a nice simplified drawing that Professor Jacob from Birmingham has done, which has a few of the little bits in it. And eventually you get a pathway that leads to these things called MAC, which deposit themselves on the muscle membrane and cause damage. And so what you want to do is stop this pathway, stop this from going that way. And the majority of drugs that have been developed inhibit something called C5, which is sort of in the middle of the pathway. There are some that have been developed to target other aspects, so for example this one at factor D. It's important to know these will only work in those with acetylcholine receptor antibody myasthenia. They won't work in patients with MuSK because the MuSK antibodies do not activate complement, so they definitely won't be helpful. They probably will be helpful in those with seronegative myasthenia. And I say that because in patients with seronegative, there has been evidence that there is complement on the muscle, but we don't know if all seronegative patients are the same. And in some or many of the clinical trials, seronegative patients aren't included, and so it's likely they'll only be available if they're included in the trials to see if they work. The one thing about complement, if you inhibit the complement system, is it can't fight off certain infections. So in particular, meningococcal meningitis would be the big worry, and so it's important that patients are given vaccination against that at least a few weeks before they have any complement inhibitor treatment. And so far, they've only been studied as an add-on therapy. So it's only been studied as, we've tried everything else, what else can we give now? Let's add on complement inhibitors. The first one was eculizumab, which is given as a drip intravenously every 2 weeks, and it was approved quite a while ago in America and Europe. Although the trial was actually negative, there were some positive findings to it. But I think because of that, the company didn't provide the required information to NICE, and so it's not been adopted in the UK. Then came ravulizumab, which is an intravenous drip every 8 weeks, and that was approved 2 years ago in America and Europe, but the company withdrew from NICE review, and so that's not currently being considered in the UK. Zilucoplan is a once-a-day subcutaneous injection. So subcutaneous injection you would usually do yourself just under the skin, often a bit like an insulin injection. And that was approved last year in America and Europe, and NICE are currently reviewing this with an expected decision in July of this year. So we shall wait and see what they think about this drug zilucoplan. I believe there is a compassionate use scheme available that certain specialists can apply to use it whilst awaiting this decision if they feel that might be appropriate. Vermercapan is a tablet, and we are waiting for trial results, which should be due soon. There's another one that's another subcutaneous injection with trial results due this year, and another one that's a subcutaneous injection once a week with trial results next year. So you can see that many different drug companies have taken an interest and developed their own sort of version, and things are changing quite quickly, and newer versions that might have particular benefits over others are coming through. FcRn inhibitors is the other big class of drugs that's breaking through. So FcRn inhibitors are sometimes called a medical plasma exchange. Some of you might have had plasma exchange, others may have heard of it as an alternative to IVIG. What happens in plasma exchange is we take the blood out and we take the plasma out and we give a replacement solution for the plasma, which is what all the blood cells swim in, and the idea is it gets rid of your antibodies. So actually in the body, your body is constantly recycling antibodies within cells, and FcRn inhibitors take advantage of this recycling system and inhibit it and stop the recycling of IgG. So it will reduce all of your IgG. Now, the antibodies that attack the neuromuscular membrane are IgG antibodies, but so are other antibodies that fight off infections. And so it would long term lower your IgG levels, which would increase the risk of infection. But it's probably beneficial compared to plasma exchange because it's less invasive. It doesn't involve the having your blood removed and given back again, and it would have less impact on other medications. So with plasma exchange, you'll remove everything that's in the plasma, including other drugs that you may have taken. And there's a lot of FcRn inhibitors being developed. So the first one is efgartigimod or Vygart, which is given intravenously. It's given once a week for 4 weeks, and then the next cycle is given at about 7 weeks later, again once a week for 4 weeks. And the idea is, or the way they've set this up, is that you have your condition monitored each week over that time. And once your symptoms are coming back, you then have the next cycle, the once a week for 4 weeks. And that can be given at the moment on an early access to medicine scheme. So there are between 50 and 100 patients who've had this in the UK on this early access scheme. Often that's given as a home care, so it's given at home. But I don't think it's a perfect drug. You have to be having intravenous drips, so that does mean cannulas into the vein every week. And you have got that period in between the cycles where your symptoms come back before you're then given the next cycle. And I think there's sort of a way to go to improve this to make it a better option. NICE reviewed this last year and did not recommend it as an add-on therapy, but is continuing to review this as a potential option. I think part of their concern is that the clinical trial that was done looked at patients who were had disease that was quite easy to treat. And their suggestion for use is to give it in patients who have had disease that's quite difficult to treat. And therefore, it's difficult to know how beneficial it will be for that group of patients. But NICE are continuing to consider it, and actually they're currently asking for people to give comments. And so MyAware have developed a guidance for posting public comments to NICE. The deadline is next week, the 29th of February, Rare Disease Awareness Day. So if you have strong feelings about this, you may wish to have a look at the guidance and then submit your comments to NICE by next week. They have developed a subcutaneous version of this drug, so Vygart Hydrolo, which is given as under the skin injection, but you can't give it yourself. It still has to be given by a healthcare professional, and it's a similar thing where you have it once a week for 4 weeks, then wait till your symptoms come back about 7 weeks later, and then start again. And it was approved in America and Europe last year, and I think the current NICE review is of the intravenous, and probably the subcutaneous will follow after their decision on that. There's another drug called, I'm going to call it Rosie, which is subcutaneous once a week. And the interesting thing for this is it's been tested in both acetylcholine receptor antibody and MuSK positive patients. And that was approved only last month in America and Europe. And there's a committee meeting for NICE to discuss this in August of this year. So let's watch this space. There's other drugs in this category being developed. This one's an intravenous one. They published a positive trial last month, which is great. And another subcutaneous one, which again published last month, positive trial. So these are coming through, and we sort of need to wait and see the decisions that NICE make about which patients it will be eligible for. Both complement inhibitors and FcRn inhibitors are very expensive drugs. I don't think we can get away from acknowledging that. Clearly, that shouldn't stop patients who need them from getting them. But it does mean that NICE have to think carefully about who should be eligible, which patients should be given these as options. I'm going to move on to getting rid of B cells. So we do that at the moment already. In certain patients, we decide that the B cells are the ones that make the antibodies. Let's deplete them. Let's get rid of the B cells. And so at the moment, we use rituximab. Now, all immune cells have little proteins on their surface, and most B cells have something called CD20, this little protein here. And so if you give anti-CD20, it gets rid of all of the cells that have that protein on. And so rituximab we use at the moment We give it intravenously 2 weeks apart and then repeat that 6 months later. And actually, recently, we have been using it without a proper clinical trial, but there have been 2 recent trials published. One was called BeatMG, and that actually came out as negative, as in it didn't show a benefit compared to placebo, but in part because the placebo group did really well. There's then another trial been published called Rhinomax, which looked at using rituximab when someone's very first diagnosed with generalized disease. And what that showed is if you just give a small amount, as someone's first initially diagnosed, you can lower the amount of steroids they need down the line. I think that's really interesting, but might take a little bit of time to kind of roll through into the guidelines and into clinical practice. Now, rituximab doesn't always work, probably works in about half of patients. And so actually what we probably want to do is, rather than getting rid of all of your B cells, is get rid of the B cells that are making the antibodies. And the B cells that are making the antibodies are actually these long-lived plasma cells. And these express slightly different markers. They lose their CD20 expression and they express things like proteins like CD38. And CD19. So CD19 is all of these B cells, and there's a drug that's been developed and is in trial to get rid of all of these types of B cell. There's a drug that's been developed that targets some proteins that promote the survival of B cells. There's a drug here and a few others in this category that stop the T cells from promoting survival of B cells. And then there's certain treatments that try and get rid of these long-lived plasma cells that have CD38 on them. So there's anti-CD38 drugs, but there's also treatment called CAR T, which reprograms your own T cells to then target these long-lived plasma cells. So there's lots of sort of research going on in this area to try and find the best way forward. The other strategy that's being looked at is modulating the interactions in the immune system. So we know that the B cells and the T cells with IL-6 promotes a lot of inflammation and autoimmunity. And so there's an IL-6 receptor antagonist being developed in trial, another anti-IL-6. The other drugs potentially that are in trial that just modulate the immune system in general are subcutaneous immunoglobulin. So many of you are aware of IVIG, intravenous immunoglobulin, which seems to work by just disrupting the immune system. It washes a load of immunoglobulins in, and the ones that are causing disease get disrupted and stop causing the illness. Now, subcutaneous immunoglobulin probably has less risks than the intravenous form, and there is a trial underway. Stem cell transplant has been shown to have some benefit in myasthenia, but it's very risky, and I'm hopeful that we can find a treatment that's less risky and just as beneficial. Really what we want is to treat something specifically. So we don't really want to be immunosuppressing people and getting rid of your immune system so you can't fight off infections. We just want to target the actual problem. And in myasthenia, for most people, we know what the actual problem is. So for example, in MuSK, if we could get rid of those MuSK antibodies, then that would improve the condition without affecting anything else. And there's been a treatment developed called MuSK CAR T, which again takes out your T cells, goes to a lab, they're reprogrammed so that they target any B cells that are producing MuSK antibodies, and then infused back, and they get rid of just those ones. So that's really exciting and is in trial at the moment. There's also some early studies about nanoparticles, which sounds very futuristic because it is. The nanoparticles, again, are programmed to try and make your immune system become tolerant to the acetylcholine receptor antibody. And I think that's really exciting. The other way you could do that is using mRNA, a bit like they made the COVID vaccines. You could make that so that your body reprograms to become resistant to those acetylcholine receptor antibodies. So this is all in early studies, but I think it's coming, and I think it's really exciting. Finally, I'm just going to mention this drug that's being developed for a form of congenital myasthenia called DOC7. You'll know if you have DOC7 congenital myasthenia, which won't be many of you, if any, but there is a drug in trial specifically for that condition, which will be very exciting for those people. Right, I said I'd talk about diet and then regretted it slightly, because diet is a very big, slightly controversial topic. Unfortunately, it's not as well funded as many of the drugs that have come through that are funded by pharmaceutical companies, because they have to, the pharmaceutical companies pay a lot of money to run drug trials, and then they get that money back through selling the drugs. And unfortunately, they don't make money back through selling you some broccoli. So there's not many sort of strong research studies around diet and myasthenia. We have seen that there's an influence from gut bacteria. So certainly gut bacteria influences the immune system. There's been seen to be changes in general autoimmune conditions and changes specifically in myasthenia. But we need more research to determine exactly how best to influence this. And so there's various papers that suggest certain specific organisms that could be given. But really, I think at the moment, the best evidence we've got is that trying to promote a good bacteria using fiber from vegetables and fermented foods is probably the best thing you could be doing at the moment with the current evidence we've got. There is an association between vitamin D levels and myasthenia, and there's been a small study which did show potential benefit of giving vitamin D replacement. And that's interesting. We know that there's a link between vitamin D and MS, another neurological autoimmune condition. In MS, patients are recommended to take regular vitamin D supplements. In fact, everyone in the UK is recommended to take regular vitamin D supplements because we're nearly always deficient because we don't get enough sunlight exposure. Many of you who are on steroids might be on ADCAL as well. Just to point out that in ADCAL there's about 400 units of vitamin D. So if you're taking that twice a day, 800 units. But in MS, they recommend taking around 4,000 units a day. So one option would be to source some vitamin D supplements around 4,000 units a day. There's some new German guidelines which just suggest checking the serum level so we can check it in the blood and then treating it to get it in the normal range. And that seems quite a sensible approach as well. Um, and finally, I'm just going to talk about processed foods. I think, there's lots of different food categories that potentially could be tried to be avoided. But really, it's a very individual thing, and it's going to be very difficult to tease apart everyone's different diet. But I think what we know is that the Western diet has become very over-processed. Ultra-processed foods are any that are made in a factory with more than 5 ingredients. And these are unnatural foods that didn't exist in our diet, until relatively recently in history. And these have been shown to be pro-inflammatory. And so I think if you're going to do anything, try and think about how you can move to a more whole food diet and away from anything that's processed. Trying to cut out things like sugar and maybe even flour as well. Exercise, there has been quite a few studies looking at exercise and myasthenia. In the past, I think it was perhaps thought of, oh, well, there's no point in patients with myasthenia. You get muscle weakness if you do anything, so why try and exercise? But actually, recently there's been 2 systematic reviews. What a systematic review is as a researcher has looked at all of the trials and put all of the evidence together from those trials. And these looked at a sort of total of about 10 studies which looked at exercise and myasthenia. And they concluded that these studies were overwhelmingly positive in favour of exercise. And that includes both strength resistance training, so sort of weight training, as well as aerobic or endurance training, so walking, running if you can. And that improves muscle strength and daily functioning. Respiratory muscle function has been shown to improve with regular aerobic exercise. So in one of those studies, it was asking people to try and walk for 30 minutes every day, and that showed an improvement after a few weeks. They did conclude that it seemed to be particularly valuable around the time of thymectomy, but I think that's probably just they've looked at it more around thymectomy because it's quite easy to get hold of people. But how to exactly tailor it to an individual is unclear. I think trying to do as much as you can regularly is a good thing. And then I'm going to move on to biomarkers. biomarkers are really important to help us guide things, and especially with these new different treatments becoming available, we'll need to know how to target different groups of people who would benefit from the complement treatments, who would benefit more from the FcRn, who would benefit from other things. So to start with microRNAs. MicroRNAs are so our body is made up of DNA, which programs how to make our cells and our proteins. And microRNA are little messengers with some of that code in. And actually, they've found that certain microRNAs are elevated in myasthenia compared to controls and in certain groups of people. So, for example, this microRNA is higher in those who have ocular myasthenia, who are then going to go on to generalized myasthenia. And that's something we've been looking for a long time, being able to predict who's going to change from ocular to generalized. So that's not yet available to be tested in the NHS, but hopefully that will come through as an available blood test that we might then be able to say, you have this microRNA, and that means you're more likely to develop generalized, or you don't, so you'll probably remain as ocular. Some of the others are up in different types. I think that's probably going to be the most useful. Some of these others are just generally a little bit non-specific and just markers of inflammation, really, and autoimmunity. We've also looked at complement. So as we mentioned, the complement system is activated, and there's these new drugs that might target that. And it's been shown by a few different people that you can measure some of these little complement proteins, and they're elevated in the disease. And what we found in some of my research is that you can see that they're higher in those that have refractory disease that's been very difficult to get under control. And so it may be that we can measure these and then say, right, this person might benefit from a complement inhibitor. But a bit more work needs to be done to develop that. And most of my PhD research has been looking at the immune cells and seeing if we can actually find ways to measure certain immune cells in the blood to decide how to treat people. And initially, I was hoping to just look at the levels of the B cells and the T cells to see if that was beneficial. But what we're finding is that actually it's more important the type of B cell and T cell that are there. So, for example, the B cells in myasthenia, and particularly those with refractory myasthenia, are more mature. They express more of this CD27, which is a protein on the surface, and therefore they're more likely to produce these antibodies. And similarly with the T cells, what we're finding is that there's lower of these regulatory T cells. Regulatory T cells try and dampen the inflammation back down, and they are lost for whatever reason in the condition, as are dendritic cells, which again try and promote immune tolerance. And so that's potentially useful as a marker that someone needs more aggressive treatment, or it's telling us that actually we shouldn't be immunosuppressing people. We should be promoting these Tregs and these dendritic cells. And we know that, for example, vitamin D, one of the ways it works is by promoting regulatory T cells. So, time-wise, we've not done too badly, little over. There's been an explosion of research in myasthenia recently. There's still a lot of work to be done, but a lot of hope for the future. So, I think we're now going to try and open up the chat for any questions. And if whilst that's happening, whilst you're popping your questions in the chat, if you've got any, I'm just going to summarise the results of this research questionnaire that many of you filled out. So we asked you, what was your worst symptom? What was the symptom that affected your quality of life most? And for a quarter of you, it was double vision. Now, for a quarter of you, double vision was the least. And so I think it depends on what symptom you have. And that's the problem with myasthenia. And it's one of the difficulties in researching it is that everyone's different. Everyone's an individual. And it's so varied that it does make research quite tricky. But double vision clearly is a problem if you have it, as is general fatigue. And I think in the past, general fatigue was not seen as a classical symptom of the condition, but that's increasingly being recognised that it is a problem, as it is in many autoimmune chronic conditions. And actually, when I averaged out the worst symptoms overall between everyone, general fatigue came out as top as the worst symptom, followed by difficulty eating and breathlessness. And we asked which services would most benefit your quality of life. And what came out top was better means of communication with your healthcare providers. And I can see why that's really important. This condition's really variable, and I think it can be quite scary when things start to go wrong. And I think it's really important that you have good means of communication with your healthcare team. Clearly, that varies around the country between different units. But we are trying to find ways to standardise care and improve um, how we do that. A specialist nurse came out second, and I think that goes hand in hand with the first one in that they are really important. And again, I think it's really exciting. Recently, MyAware have managed to find some funding to try and help support some specialist nurses around the country. I asked what was the biggest need that you felt for patients with myasthenia, and came out on top was better symptom control. And I think that's recognised generally in the research literature at the moment, is that we're realising that we may have improved patients' conditions, but many patients do need better symptom control, which is personalised and have fewer side effects. But alongside, I think, clearly you will recognise the importance of non-drug management of the condition as well. And I think that is under-researched in part because it can be difficult to find the funding. And when considering treatment options, you pretty much all went for how well it will work, which I would agree with. I think it's really important that treatment works well, but also clearly it's important risks and side effects, how quickly it will work, because many of the drugs we use at the moment do take months and months and months, and that's time that you have lost. Time that you can't work or you can't interact with your family as you want to, and I think that is a really important point. And the treatment's effect on other conditions or interaction with other medications is clearly quite important to you. And then the importance of research in other related areas. So infections and vaccinations, I think with COVID, recently it's at the forefront of many of our minds. We know that infections and vaccinations, promote the immune system, and therefore autoimmune conditions like myasthenia can get worse after an infection or a vaccination. But has this been researched enough in myasthenia? Maybe not. And the interaction with other illnesses is also very important. And then there was a lot of other extra comments, and I have read through them all, and I'm really grateful. And this is just a sort of summary of some of the ones. I want to pick out a couple. Long-term plan for treatment. So this was one thing that we were quite interested in Manchester, in that patients are started on immunosuppression. We know that generally the condition is worse in the first year or two and tends to stabilise. And then what do we do? Do we leave people on immunosuppression long term, or do we bring it down? And there's some retrospective studies, so studies that have looked back, at what's happened to people. And these have shown that you can actually reduce the usually without too much trouble, but not many people, about 10% perhaps, will get off treatment completely in the long term. Better coordination of research efforts, I would agree with. And I think, particularly in the UK, I think we are recognising that, developing more regular meetings between researchers who are interested in myasthenia. And there's also now this development of a myasthenia database, which I've not talked about today because I think there was another webinar about that. But hopefully that will roll out and help us to coordinate and find out what's going on nationally with myasthenia and with patients. Avoiding corticosteroids, I think I'm just going to acknowledge is important, and will be something that researchers are looking to try and do with new drugs. But I don't think at the moment we've found a good alternative that can be used quickly at the start of the treatment. And that's what we need to do, is develop research trials that look at how we could treat patients as they're first diagnosed, to try and bring things under control without these drugs that have loads of side effects. And how to get into trials was asked, so I'm just going to briefly touch on that. If you are interested in getting into clinical trials, then they're all registered at clinicaltrials.gov, which is a website. And what you can do is you can search for your condition, and then you can put some filters. And I think I put filters of currently recruiting, with a using a drug that might treat the condition for adults. And actually, there's 2 at the moment in the UK at about 5 different sites that are currently recruiting. But before you all rush in and sign up, there will be contact details at this website, but there will be strict inclusion criteria. So it may be that you don't fit the inclusion criteria for that study that's being run. So they will be listed on this website, though, if you click into these. Most trials are done as a randomized trial. Half of the patients get the drug, half of the patients get a placebo. So there's a 50-50 chance you get a placebo. And if you did get the drug, it may be no better than what we've got currently. It may have side effects. So, new drugs are not always better drugs. I think it's great that things are being developed and things are changing, but we're going to have to go through a lot of different trials before we find the best treatments for the condition. Okay, so I think we're going to move on to questions.
Yeah.
Tracy, shall I do the pre-agreed ones?
Yeah, let's do a few of those first and give you time to think because that was incredible. So thank you. We did have some questions in beforehand. We had lots in. We've cherry picked a few, and we know a lot of were covered in Dr. Dodd's presentation. So bear with us. We've also had quite a few in on the Q&As, and some of them are quite specific. And we can only really do generic ones today. So bear with us. Unfortunately, Dr. Dodd has lots of her own patients, so we can't necessarily do specific ones today. But I'm sure she'll have a look through shortly and see if there's any of those we can pick up. So if we go to the first question that was sent in, and we'll see how we go with that. So what is being done with medical professionals to help recognise myasthenia symptoms sooner so that diagnosis can be speeded up? Do you want
So
me to answer this one, or are you okay?
well, it's up to you, Tracy. I mean,
No,
I
you
think,
take this one from your point, and then I'll add my awares a little bit after.
yeah, great. Yeah, from my point of view, I think that myasthenia specialists, if you get there, are quite happy with making the diagnosis in the majority of cases. I think we have good tests generally. We have the blood tests. If on the antibody tests that are available locally, there's the specialist tests that can be done at Oxford, which can be really useful. There's also electrical tests that can be done, but most of the time it's relatively obvious to a myasthenia specialist. I think the problem is that patients need to get there, and if they're seen by a generalist, then often it isn't picked up for a long time, and so it's trying to. The most important thing I think is awareness and making awareness with general healthcare professionals. What do you think, Tracy?
Yeah, and my aware are doing that this My Awareness Month in June. We're doing a big campaign with general practitioners. The feedback from our survey was 83% of you wanted GPs to be more aware of the condition, and that's what we're doing. There's lots of exciting stuff coming up. It's all going to be on our social media channels. We're going to be sending stuff out to members. It's a very exciting time. There's lots of things going on behind the scenes that we're not necessarily allowed to talk about at the moment, but bear with us. We are going to be shouting about it as much as we can. So there'll be lots of information coming out to members on how you can get involved and how we together can help raise awareness with GPs and hopefully get that diagnosis speeded up and getting everybody to the right people.
Great. And so next
Okay.
one. Sorry, I changed this slightly because I think
That's
there's
okay.
2 questions in this.
That's fine. Does everybody with myasthenia have detectable acetylcholine antibodies? Do you want to take that one
So,
first?
so no, 85% do. Then there's some patients have MuSK, some patients have LRP4, some patients are seronegative, but about a third of those, if you send the blood to Oxford, have the antibodies detected on their special way of doing it called cluster antibodies. But there are a group that don't have antibodies and still have the condition.
Okay. And should a person without myasthenia ever have any detectable acetylcholine antibodies?
So I think that's what this question was asking. I yes. So the body in a normal person, you can have a low level of acetylcholine receptor antibodies because of that system in the thymus. It's making antibodies against everything. But what's meant to happen is the immune system's meant to recognize that that's abnormal and shut it down and not let it develop. And so in most tests that we do, there's a sort of cutoff level where up to a certain level, it's normal to have a very low level of acetylcholine receptor antibodies, but above a certain level, that's abnormal.
Great, thank you. So we know myasthenia symptoms can fluctuate and move from place to place and throughout the body. So what do you think are the reasons for this? And are there any known triggers?
So really interesting, and I think we know that they fluctuate for a variety of different reasons. So people report differences in the heat following infection, around the time of their periods. So there's a lot of different things that influence, and I think that's different things that influence the immune system. And as the immune system ramps up, things seem to get worse. Um, but this moving from place to place, I don't think we fully understand. We know it happens, but again, we don't really understand. Some people think that perhaps there's perhaps a shift between some patients having a lot more problems with their complement system being activated, and at other times it's the antibodies blocking the receptors being the problem, and that might make a difference, but that needs further study.
Great, thank you. And is there any information about what causes and worsens autoimmune conditions?
So I think that links in to the last one a little bit. The cause, we know that certain people's genetic makeup makes them more prone to autoimmune conditions. So it's not just one gene, but lots of different genes will make you more at risk of an autoimmune condition. 1 in 3 of us have an autoimmune condition. So autoimmune conditions in general are very common. And those that have one are more likely to have another autoimmune condition as well. And so many of you will have not just myasthenia, but other autoimmune things. And then I think autoimmunity in itself is comes back to that thing we discussed about the immune system and things that will worsen it. So anything that ramps it up, such as an infection, you'll often feel a lot worse with your autoimmune condition when you've got an infection because your immune system's ramped up, and we need to kind of calm it back down again.
Great, thank you. Are there any food and drinks that we should limit or avoid?
So again, slightly controversial, goes back to my general advice would be try and avoid processed foods and go for whole foods. I think it depends who you ask, and there's a lot of different opinions on this. Some people will promote, for example, a low carbohydrate diet, ketosis. Some people would recommend cutting out gluten, wheat, dairy. But I think, as an individual, you need to have a think about what might be achievable, have a look at your diet, maybe try and do one thing at a time and see if you find it makes a difference.
Yeah, great, thank you. We got any more on here, or did you want to have a
Uh,
quick look in the chat?
sorry, I think there was just a
Oh, we
couple
got one
more.
more.
Go on,
A couple more.
just
Okay.
take.
So does statins have an impact on myasthenia gravis?
So this is a worry about for quite a lot of people, isn't it? And there are occasional case reports of people taking a statin and it worsening the condition. But there are lots of people with the condition who take statins and are absolutely fine. And statins play a really important role in reducing the risk of heart attack and stroke, which can be, fatal. So my general advice is if you're not on a statin at the moment and someone thinks you should be on one, is to start it when your condition is stable and then see how you go. And if your condition worsens after starting the statin, then stop it again and explore alternatives. But it's most likely that you'll be absolutely fine.
Great. Yeah, we have some information on our website on statins, so there's
Great.
always there. You can have a look at that as well. Right. Is it possible that advances in treatment for other conditions such as multiple sclerosis or Parkinson's disease could help doctors understand and treat myasthenia? If so, are there examples of this?
So I think much more multiple sclerosis MS compared to Parkinson's disease. There's a lots of overlaps with MS and myasthenia, although MS affects the central nervous system, so the brain and the spinal cord. It is quite different to myasthenia in that way. But they're both autoimmune. And certainly in MS, there's a lot of benefit from B cell depletion. And so they don't use rituximab. There's a lot of newer drugs that help target B cells that have been developed for MS that are used quite widely there. Now, they've not all been studied in myasthenia, and so we're not currently using them. And I think in part because there's now this thought that actually should we be targeting all B cells or should it be these more advanced, plasma cells? So I think there is a lot of parallel with MS, probably less so Parkinson's disease.
Okay, thank you. And possibly the last one for here, is there any emerging research that a more aggressive approach in the treatment of myasthenia is beneficial in the early stages?
So it goes back to that trial I mentioned about using rituximab at the onset. Low dose rituximab, as someone develops generalized condition, seems to lower how much steroid you need. And I think that's something that we probably will start moving towards in the coming years. It's not quite rolled out, we don't quite know who to do that to, though, because probably not everyone needs it. And so, do we give it to everyone and then put people at risk of infections that didn't need that treatment, or do we do it so that overall people need less treatment? It's under debate, I think, at the moment.
Okay, so watch this space with that one as well.
Hmm.
Okay. I don't know if you wanted to have a quick look in the chat at the questions that have come through. I'm going to launch the poll if that's okay,
Yeah, sure.
because we are a little bit short on time.
Yeah.
So just bear with us. So poll questions going to pop up on your screen now. There's only 5 questions, very, very straightforward. We'll give Dr. Dodd time to catch a breath and have a look in the chat. And it's just a little grey scroll bar at the side, just to scroll down through those. So we just give you a couple of minutes to do those. Okay. Nearly finished with those poll questions, and then we'll pick up a few from the questions that have been answered to us tonight. There's been a lot in there, so please bear with us. They're not in vain. We will take them. It might take us a little bit of time. It might be a little bit of a project, so bear with us, but we will do our best to get some answers for you, for those questions that you've popped in the Q&A tonight. We really appreciate people that answered them before and have asked them tonight. It really helps us develop how these things go on. So thank you ever so much for your filling the poll in, and for sending all your questions in. We just are a little bit short on time tonight. So while the last few are just finishing off the poll questions, the first one we've got in there, is, will there be some more research? Is that seronegative? My
I
eyes
think,
are a
yeah,
bit
they're asking about
tricky.
seronegative and will there be more treatment options for patients with seronegative disease? So I think the problem is that there are less people with seronegative than acetylcholine receptor antibody positive, and so
Yeah,
most of the trials focus on AChR, but there are some trials that have included seronegative patients, and so I think some of these drugs will come through and hopefully be available for seronegative patients.
great. I think the next one is there a link for treatments or susceptibility with other autoimmune disorders, such as thyroid, or I think that's psoriasis?
Yeah, so I think that's I think that's an area of research that really needs to develop. Of we know that patients with autoimmunity have multiple conditions, and how can we give a treatment that will target a combination of their conditions? And so we do sort of do that at the moment. If we know someone's got two conditions and one drug would be particularly good for both of those, we do try and do that. Um, I think psoriasis can be a little tricky, but a lot of patients might have, for example, rheumatoid arthritis as well. And we know that rituximab would work perhaps for both that and the myasthenia. And so we might have a slightly lower threshold for using that.
Okay, great. And how do I know that I'm ready for a thymectomy?
I think that's a slightly tricky one. I think you need to do it in combination with your healthcare professional, but in general, we would recommend it to be done once you're stable. So, although it needs to be done relatively early in the disease, it's really important that you're well enough to have what is effectively major surgery. And so, usually, patients, when they're first diagnosed, will be on treatment that's being increased until they're brought under control. And really, it's at that point, once you are under control, as soon as you're under control, at that point, I would try and go for a thymectomy as soon as you can.
Okay. I think we're done for questions. We are at our time. Anything you
Fab.
wanted to say, Dr. Dodd, before we
So I
finish?
just want to say, if anyone wants to fill in my questionnaire about research and myasthenia, this is the website that you can go to, tinyurl.com/research and myasthenia. But then I'll
Okay.
also move on to your final slide.
Yeah, just wanted to say thank you actually for you joining us as our members, and certainly to Dr. Dodd for that incredible presentation. We learn every day here, as a team, and I'm sure our members have learned from you today as well. So thank you ever so much. If anybody does want that link to Dr. Dodd's presentation or to the survey, you can always drop an email to support@myaware.org and we can certainly pass that on to you. Um, I think all that's left for me to say is thank you for joining us this evening, and thank you, Dr. Dodd. It seems like there's a lot going on in the world of myasthenia, and certainly for me, there's a lot of exciting times ahead. So
Yeah, I
thank you
think
ever so
watch this
much.
space. I think
Yeah,
a bit of patience, but I'd be happy to come back, in the future and update and let people know how things are going.
take that as you're booked. I think it's been great, and we would love to have you back. I look forward to all the feedback from all the members. Certainly from the poll questions, everybody's thoroughly enjoyed this evening. So thank you ever so much. If you are able to help MyAware, the scan screen is there if anybody is able to donate. Thank you ever so much. We hope you found the session interesting, and we will see you very soon.